Buenas tardes. Today we're talking more about quadratics, surprise, surprise. This time we're going to find vertex and axis of symmetry, and we're going to go over one word problem. Make sure you got this outline before you start so you don't have to rewrite all of this. All right, vertex, that is the minimum or the maximum point. In other words, if you have this nice little curve, this parabola, it's where it turns around. If you have an equation to find the vertex, first, guess what form you're going to put it in? That's right, standard. And the vertex will be this for your coordinates. The x-coordinate will be negative b over 2a. And your y-coordinate is whatever y goes with that, which we call f of negative b over 2a. And if you don't get what the crud I mean by this, don't worry, you'll see what I mean in just a moment. A little reminder, if you're trying to graph this on a calculator, remember that the vertex is the minimum or the maximum. So if you can find the vertex, you know where to change your window so you can see the important parts of your graph. Let's look at an example. We have this lovely equation. We want to find the vertex. So first, is it in standard form? Heck yes it is. Awesome. So we need to find the vertex. It'd be helpful to know what A, B, and C are. Well, A is 1 because there's a 1 hiding there. B is negative 4, and C is 2. So we said the x-coordinate for the vertex is going to be negative b over 2a. So let's write our skeleton like that. Okay, let's fill in with what we know. B is negative 4, and A is 1. Well, remember, a negative times a negative gives us a positive, and 2 times 1, we should all know that's 2. If you heard that, that is my fridge. All right, 4 divided by 2, that's the same as just 2. But we're not quite finished. We found the x-coordinate, now we need to find the y. And what I mean by f of blah, 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 is we're going to take this number for x and plug it back into our original equation. We're replacing x with 2. So y equals x squared minus 4x plus 2. So this is the equation they were given. And instead of x, we put parentheses, and then we're going to fill the parentheses with what we just found, which is 2. And now you have an option. If I were you, I would just plug this into your calculator, exactly like that, parentheses and all. Or you can do it by hand, up to you. We get 4 minus 8 plus 2. Either way, you should get y equals negative 2. That means our vertex is at negative b over 2a, which we said is 2. And then the y value for that. So when we plugged in x, we got y equals negative 2. That's our vertex. Cool, let's look at a graph. On a graph, just ask yourself what are the coordinates of the minimum or the maximum. In other words, we got a nice minimum right here. Just ask yourself where are the coordinates of that? Well, let's look. The x-coordinate is at 3. And the y-coordinate is at negative 5. That's your vertex. And over here, here's our vertex. And the x-coordinate's obviously 2. And the y-coordinate is 0. Not so bad, right? All right, axis of symmetry. Ask yourself, where does a vertical line split the graph in half? In other words, where could I draw an imaginary line and have it look like a mirror on either side? So like right here for this graph, notice the left side just looks like a flipped version of the right side. It just flips over this axis. Well, if you're given an equation, guess what form we're going to put it in? That's right, standard. And the axis of symmetry will be x equals negative b over 2a. That's right, it's the exact formula we found to find the x value of a vertex. So let's see an example. All right, is this in standard form? Yeah, it is. So let's label A, B, and C. Well, A is 1, B is -4, and C is 2. So we want negative B over 2A. So negative parentheses over 2 and some parentheses. Now fill in your parentheses. B is -4, A is 1. And yes, if you're feeling like you have deja vu, you're not going crazy. -4, that's +4. 2 times 1 is 2. Well, 4 divided by 2 is just 2. And yes, this is the exact example we just used for Vertex. I know, I'm tricky. Well, the equation for the axis of symmetry is x equals -b over 2a, so x equals 2. This is our axis of symmetry. Let's look at the back. Okay, finding the axis of symmetry on a graph, you just need to know what is the x-coordinate of the vertex. So, for example, our vertex is right here, and the axis of symmetry would be this, which notice that's the x-coordinate, and the x-coordinate is 3. For this one, here's our vertex, and the x-coordinate is 2. So our axis of symmetry would be right here. Not so bad, right? Oh, word problems, how we hate thee. But that's okay. We're going to work and we're going to be able to conquer them at some point. So, little reminders. When you're asked about reasonable domain and range, something really important to remember is that time and distance cannot be negative. You can't say that I ran -5 feet. That doesn't make sense. Or to say that I ran for -10 seconds. Doesn't make sense. It's like going back in time. Can't do that. So, and most of the time is going to be our domain, distance is going to be your range. Most of the time. Guess what we're going to put it in? That's right, standard form. We are just in love with standard form. And make sure to label your variables. That'll help you out. And then I suggest make a sketch of it. So for example, we got a superhero. He's going to leap over a tall building because he's a superhero. He can do that thing. And they give us this function. This shows us his height in feet as a function of time. So this is what it would look like. Here's our little graph. You're going to start at time 0 and distance 0, right? Because he starts on the ground. And he jumps, whee, and then he comes back to the ground. So that makes sense. And if we double check, our A is negative. So A is less than 0. So yeah, we want it to open down. And our vertex would be right here. And that would be the highest he can jump, right? Well, here's the thing. We have a building that's 612 feet high. Our hope is that the building looks like this. We're hoping that the building fits under the vertex, right? Because then he can clear it. But if the building is taller than the vertex, he's going to go splat and jump into the side of the building. We don't want that. So when it asks us, will he make it over the building? They're really asking us, is the vertex above or below 612 feet high? Well, you know, be helpful, and I forgot to do, because I'm a bad person. I forgot to label my variables. It says the height, this is a function of height as a function of time. So if we say function of time, that's our dependent variable. That's our x. So let's make a note. Time is x. Well, that means f of x is our height. So we're worried about the height, right? So we need to find the y value of our vertex. Well, to find the y value, we got to find the x value first. So if you look back to find the vertex, and I don't know why I'm changing colors, I just felt like it. So remember, the vertex is -b over 2a, comma, f of -b over 2a. So is this in standard form? Yes, it is. Let's label our A, B, and C. Well, A is -16. B is 200. And don't panic. We don't have a c, so c is 0. All right, let's find our negative b over 2a. So we have our skeleton. Let's fill it in. B is 200. A is negative 16. Well, we get negative 200 over negative 32, which is the same as positive 200 over positive 32. And you know what? It gives us a decent decimal. That would be 6.25. Well, remember, time is x. We just found x. So time is 6.25. We don't give a darn about time. We need to know about the height. That's what's important. So if we need to find our y, that means we need to plug this in for x. So y, or f of x, I should say, is negative 16 x squared plus 200 x. So I'm finding my height. Remember, this is the height of the vertex. This is the maximum height our superhero can jump, and we're hoping it's more than 612. Let's find out. So we said 6.25. 6.25. All right, if I were you, I would just plug this into your calculator exactly like that, parentheses and all, and you'd find that f of x equals 625. Well, that means his maximum height right here is 625. So that means 612 would be under it. The building would be like this. Yay, he would be able to jump over. So yes, he would make it over the building because he can jump up to 625 feet. And he only needed to jump at least 612. That's well over what he needed to do. Wonderful. We've got some examples from the page we got Thursday. So if you don't have that paper, look at last week Thursday and get to it.